also another logistic thing, make sure the microphone's on for speakers. If you want to take the floor and speak, we'll pass the microphone around. Please speak into the microphone because we have people online listening to this session as well. And they will be able to ask questions to the presenters. And I think that's everything. Yeah, so the basic structure is we'll have a presentation today, 10 minutes each presentation, 8 minutes presentation, 2 minutes questions. And then we hope to have a 10-minute discussion at the end about some of the themes that were covered in the session. So just for those of you who weren't in the session yesterday, just to give you the framework for this session. So we want to place it all within the Kunming-Montreal Global Biodiversity Framework. So we have these 23 targets. And what we really want to focus on this session is that target 21, the data part of the Kunming-Montreal Global Biodiversity Framework. So we have this target 21 that says that ensure the best available data, information, knowledge, accessible to decision makers, practitioners, and the public to guide effective and equitable governance, integrated and so on. And what we want to really make, the key point that we want to make in here is that data is critical for all the other targets. So we want to explore through this session how data is supporting the achievement of all the other targets. So we had 2 sessions. So yesterday we had a session that really focused on the data part. So we looked at global initiatives on bringing new data to feed into the monitoring monitoring of the targets. Looked at global initiatives as well with new data sets that could be used for biodiversity monitoring. And now we want to do here in this session is we want to go from the global down to the local. So we want to give examples, national examples, want to showcase regional examples as well. And we also want to talk with sectors, different sectors, how they're contributing to the targets and tools that people have been developing that can help monitoring towards some of these targets. So yeah, so we have a great range of presentations today. I suggest we start with our first one. So we have Michelle Westerlaken from, I hope I'm pronouncing this right, from MIT Climate and Sustainability Initiative. And I will just pass you the microphone.
Thank you. This one?
Yes, let's move it forward.
All right, thank you very much. I'm just going to dive right in. So the key takeaway for this talk is that biodiversity data systems are not neutral repositories, but they are artifacts designed by humans. And my research argues that by embedding principles of vitality into their design, they can better align with the Kunming-Montreal Global Biodiversity Framework and respond to the needs of different stakeholders. So this work comes from participatory design research with technology developers, restoration communities, and researchers. And over this last year at the MIT Climate and Sustainability Consortium, I also worked with corporate sustainability specialists from these different companies. So this is a list of the companies that are involved in this consortium, and many of these participated, so their biodiversity specialists participated in this research, but some of them did not. And the methods include interviews, site visits, and participatory design workshop. And across this work, I asked, what are the biggest challenges that these different stakeholders face when they engage with digital biodiversity data through these digital platforms? And perhaps where are the biggest gaps in innovation today? So then I did thematic analysis and articulated new design approaches towards these challenges. And several publications also came out from this work. So the findings is that there is a mismatch between vision and implementation in these systems. So the KMGBF vision is actually a world of living in harmony with nature by 2050. And I think this is a very important sentence within that framework. But the tools that we are developing for stakeholders to engage with this data towards this vision actually often treats data production itself as the end goal. And also the corporate reporting mechanisms for biodiversity reinforce this orientation towards the data gathering itself. So these corporate stakeholders I talked with, they often state that they spend a lot of their resources on trying to find trustworthy and accessible data. But they don't actually need this data for its own sake, right? They need it to guide different pathways. For example, they want to establish corporate transitions towards nature-positive supply chains, or they want to be involved in local biodiversity restoration initiatives. And so the design problem that these platforms could approach more is to actually integrate this vision and these stakeholder challenges into these systems. So designing features that make biodiversity data actionable or that contribute to the sense-making of this data for these different stakeholders. Because ecosystems are not computers, right? Actually, they are maybe even the opposite of computers, because the natural and the artificial are sometimes in opposition to each other. Ecosystems are alive. They are largely unpredictable. They're often chaotic. They are often also breathtaking, but they also bring loss and decay. So what if our digital systems could perhaps reflect some of that vitality into their design? But then what does this vitality mean in practice, right? So I translated the findings of this research into a design brief, and I brought a lot of printed copies today, so I'm going to pass them around. So a design brief is a short outcome document that's aimed to inspire new forms of innovation. It's a little bit similar to a policy brief, but this kind of document is aimed at designers or developers or project managers or funders who are thinking about different features for data systems. And so, for example, this design brief outlines 3 design criteria for more vital biodiversity systems. And I'm only going to highlight the first one in more detail. But I think if we get this one right, all the other features actually can grow from this particular orientation. And this is about centering vital aesthetics. So right now, we are designing these biodiversity systems according to this kind of techno-rational or computational aesthetic. So we're trying to turn these ecosystems into machines, essentially. We are turning biodiversity into something that is computational or engineered and very structured, right? And researchers have actually argued that this risks flattening ecosystems into fragmented or engineered entities, which actually really risks erasing very important qualities of these ecosystems that these stakeholders or users need to make decisions about ecosystems, right? Because anyone who has ever spent time in the field knows that biodiversity is actually something else entirely. It's messy, it's chaotic, it can be very itchy, sometimes it's too dry and sometimes it's too wet. It can be breathtaking, but it can also bring loss, decay, and conflict. And these are actually the realities that we need to take into account for people to make decisions about the future of these ecosystems, right? In, for example, corporate transitions, but also in local restoration practices. So my argument here is that these data platforms should reflect these much broader aesthetics and bring them also into these digital systems, aligning digital systems much more closely with, essentially, with ecosystems themselves and our lived relations with them. And this KMGBF vision as well, right? That should be a guiding principle for the design. So I'm also collecting examples of projects that I think can align with this vital approach to show that this type of design is actually possible in practice and maybe to inspire other kind of systems as well. So one example is called Pollinator Pathmaker by artist Daisy Ginsberg. It's an online tool that uses pollinator data to design gardens not according to human aesthetics, but speculatively according to how a pollinator would design a garden. And these gardens are also then planted in real life. So it also emphasizes that these pollinators can then respond back to these types of human ways of interacting with ecosystems. So the data doesn't just stay online and digital, it becomes something that these pollinators then also respond to by changing the gardens accordingly, right? So this tool can actually inform quite practical decision making on how to, what kind of garden to plant. And this, another one comes from a recent design research paper. So this is a forest simulation tool that lets users explore different data sets about urban forest. And here, the urban forest entities can actually hold conflicting perspectives. So it makes the trade-offs and the complexities actually very visible in the data. So it creates a system where conflict between different entities in the forest are brought into the foreground and not like avoided by trying to smooth out the data as if this is like a kind of one-directional information system. So this tool could perhaps inform decisions on how to negotiate these different trade-offs in urban planning, for instance. And then lastly, also indigenous practices offer very rich inspiration. So for example, the chumbe weaving of the Camancha indigenous people in Colombia, creating these belt patterns that depict biological or ecological data as well about harvests or sowing or lunar phases. So what if these types of ecological data formats could become the inspiration for design systems as well? So such a tool could inspire us to rethink like what is ecological data, what does it involve, and how does it relate to people's lived experiences. So on the project website, I'm also sharing more details about these examples. And I'd also love to learn from you if you think of any example that could perhaps expand this catalog. So all the resources from this talk, the design brief and the publications and the examples are available through this QR code, but also in the printed copies that I brought that I will share. And also my invitation to you is to get in touch if this somehow resonates, if you are perhaps thinking of new data features, if you're rethinking design, rethinking practices for digital systems, or if you're maybe organizing a hackathon and you want to kind of see what kind of approach this could lead to, or if you want to perhaps engage more with design research, please get in touch. So in conclusion, the findings of this research and the creative process suggests that the KMGBF vision could be better supported by designing data systems that actually embody the richness, the vitality, and the complexity of ecosystems. And this would then also help the different stakeholders to use these systems towards that very same vision. Thank you very much, and I'm happy to answer questions. Do you wanna
Okay, so we have some time for some questions. Yeah, we have one here.
Just one question, because it makes me think about a lot of things, but just it seems to me that a lot of things who are on the slide are the vision of the biodiversity by humans and not biodiversity itself. So I don't know if this is something common to can.
Yeah, absolutely. I think it would be super exciting to engage with who are actually the main stakeholders of the systems that we're developing, right? Which are these more than human entities who we are observing right now. So how could they also become agents in the design of these systems? I think the example I showed second with the simulation tool that brings these different perspectives from forest entities more into the foreground could be a really great example to engage with that more. It opens this huge box of inspiration for design, I think, right? Once we get over this human-centered design and make it more maybe planet-centered or ecosystem-centered. So thank you so much.
Any more questions? No? Okay, well, thank you very much. We'll pass on to our next presentation. So now we have Courtney Davis from Cornell University. Hand it over.
Thank you. Can everyone hear me okay in the back? I'll make sure to project, but I realize that this doesn't actually work in the room, so I want to make sure you all can hear me. Good morning, everyone. My name is Courtney Davis. I'm an assistant professor at Cornell University. Today I'm going to talk about the Biodiversity Progress Index, or the BPI, as I might refer to it. It's an approach and a tool that we've been developing over the last couple of years to really get at sort of the needs within the global biodiversity framework, but also sort of more generally when we think about reporting for biodiversity. And that's really a tool that's scalable, cost-effective, and actionable. This tool relies on the use of birds as indicators of biodiversity, sort of making use of one of the largest biodiversity databases in the world, eBird. For anyone that's not familiar, eBird is a mobile application where anyone, anywhere in the world can submit observations of birds. It is available in over 90 languages worldwide. And that has led to sort of a global expansion of its use in the last decade or so. We've now topped 2 billion observations by 1 million users. And while it is sort of global in extent, there are obvious sort of data gaps still within this database, as there are with others. And there are challenges that come with using participatory science data from eBird, as well as from other sources. And so the Biodiversity Progress Index addresses these challenges in a variety of ways. We use detection, non-detection data from eBird users, as well as count data. We fill in some of the spatial gaps that are present in those data by linking those observations to a series of environmental covariates. So right now, a suite of 120 to 150 largely remote sense covariates. We deal with some of the spatial and temporal bias that are associated with these data through a spatiotemporal grid sampling approach. So this allows us to essentially balance out the data both in space and time. We include additional covariates outside of our remote sense environmental covariates that allow us to deal with variable survey effort. So knowing that when people go out to collect data on birds, they're not all collecting data in the same way. And then finally, we include an additional set of covariates in our model that allows us to account for differences in how people bird, their skill level, all of those sorts of factors that we know are important. And we do this using a checklist calibration index, which has been developed independently by collaborators at the Lab of Ornithology, but really gives us sort of a standardized index to look at how behavior changes across space and time. And we combine all of this into our deep learning joint species distribution model. If anyone was at my talk yesterday in the Overcoming Challenges for Biodiversity Monitoring session, I talked about the methods of this model, so I won't go into any detail here, but I'm happy to answer questions at the end or talk to folks. This is a hurdle model, so it allows us to estimate both occurrence as well as relative abundance of individual species, and we can do this for hundreds to thousands of species at a time. So from this approach, and what underlies the BPI are species level products, like I've shown here for the Quetzal. So we have maps produced at a 3 kilometer by 3 kilometer spatial resolution for both occurrence and relative abundance. We've generated these at a weekly to monthly temporal scale throughout the full annual cycle. So that allows us to capture how these birds are changing in their distributions across space or across time. The BPI also has a suite of community level data products such as species richness, which I've shown here for an example of a set of warbler species. If we think about how we report or talk about biodiversity, though, especially within this framework, using metrics like species richness don't provide us sort of a reliable or consistent metric across which to compare different sites or different habitats or even different countries, because there are a lot of evolutionary practices or evolutionary processes that determine how many species can occur in any given location. So if I were to compare the Andes region of Colombia to the northeastern US, for example, the Andes region would always have more species. And so the BPI uses the metric of community completeness as its benchmark metric. And this is a metric that essentially allows us to standardize those estimates of species richness to understand the proportion of species that are present at a location given the species that could be present at that location. So here's an example for all of Central America using data, again, from eBird for about 2,000 species. This metric is produced at a 3 kilometer spatial resolution as well as a monthly temporal resolution. And we actually estimate the species that are missing using a data-driven approach, the Beal's co-occurrence index. And this allows us to also identify potential conservation targets. So these are species that could occur within that community assemblage, but are not predicted to occur for some reason. That could be due to human influence, disease, any number of factors. And this method has been described in previous publications by Lewis et al. In 2016. So completeness is then sort of the simple proportion, the number of present species divided by the total number of species that could be present. And that gives us sort of a easy to understand metric for decision makers. It ranges between 0 and 1. It is sort of that proportion of species. And so it gives folks a sort of clear understanding of potential ways to improve that number. It also gives us sort of a consistent metric across different types of programs and sectors. So these are two examples in Costa Rica. One, the Protected Areas Network, and two, sort of all coffee grown within the region. This is completeness of species of conservation concern, so we can break this up into different groups as well. And the areas that are in red are those that are less complete, and areas that are in green are those that are more complete. Sort of gives them sort of a relative measure of performance across these different sectors. As sort of a little heads up, we can also use this metric to look at the impact of nature-based solutions. So I'm not going to talk about this in any great detail because my colleague Viviana will be talking about this in the biodiversity and business section tomorrow. But we can use this to actually look at sort of the impact of regenerative practices at the farm level. So here we see that for farms that have implemented agroforestry for longer, have higher sort of biodiversity according to our index. And then finally, we can use this metric to look at change in biodiversity conditions over time. So this is an example of a coffee growing region in Colombia. And we can actually look at how biodiversity, this completeness metric, has changed between 2 years and how that relates to changes across the landscape. So here we see that farms that have become more fragmented in tree cover have lower biodiversity in 2021 compared to 2019. And those that have become less fragmented have higher biodiversity. And so finally, just to sort of conclude, I'm not going to flip through all those. This is a metric that can be used across different scales, countries, regions, habitats, time periods. It does require that there are available sort of high-quality eBird data and does require some fine-tuning of the model itself. But in essence, it is sort of a cost-effective and reliable approach and does allow for a lot of region-specific implementation. So with that, I'm happy to answer any questions. Take this off.
Thanks. I can see a question here at the back.
Hi, very interesting work. I wonder, though, if you might rephrase Biodiversity Progress Index to Bird Progress Index, since it seems like this is just based on bird data.
Yeah, that's a great question. So we do call it the Biodiversity Progress Index because birds can be reliable indicators of biodiversity. There are lots of studies sort of showing that. And they can be reliable indicators of environmental conditions and that they're sensitive to change. We have developed this using birds, but we are also talking about how to integrate information from other taxa as well and sort of validate or validate the information provided by birds from other taxa. So I appreciate that.
Thank you very much for your presentation. Quite interesting presentation. Yes, in estimating the index of completeness, it is the number of species present divided by the number of species present plus missing species. How did you estimate the missing species?
It's only just beginning, too. It's the second talk. Yeah, that's a great question. So we use a data-driven approach to estimate the species that are potentially missing from a site. And we do that using co-occurrence patterns across all species that are present within the region of interest. So it actually looks at co-occurrence across, let's say for Costa Rica, we had 875 species that we were looking at. It actually looks at co-occurrence patterns across each pair of those 875 species and makes a data-driven approach based on thresholds of those co-occurrence probabilities to say, this species could occur within this assemblage, or it could not. So we actually get a probability that a species is part of that missing community. Happy to talk more about that later.
Great. Let's give it a hand to Courtney. Yep. So next up we have Lina Estupinan-Suarez from IDIV.
Thank you, Andrew. So yes, I'm a Colombian researcher working at IDIV, and I will talk about what we have been doing for more than 2 years in the biodiversity building blocks for policy. The title of my presentation is Leveraging Data to Inform Biodiversity Policy, and I want to start just saying that this is a work that has been conducted for 13 institutions, mostly based in Europe, but we also have partners in South Africa and Australia. And the spirit behind what we are doing is really mobilizing data in a fair way, and we want to go far beyond fair principles. We just don't want only to have fair data. We also want to have fair indicators, fair workflows for informing the Kunming-Montreal Global Biodiversity Framework. This is the main core of our work. And this is also published in a paper. It was released 2 months ago, led by Quentin Groom. He's also here in the house. And the idea here is that we have a community. It's not just scientists, stakeholders, conservationists, citizen science. We all need data for decision making. And this data also need a framework, and every day more and more data is produced. And we also need solutions for working with this big data. So in this case, we are taking the data cubes approach to facilitate this data management. And with this also we can move forward to automated workflows that can be working in the cloud computing. So just briefly about the Essential Biodiversity Variables Framework, I just want to say that it's a framework that has been in place for more than 10 years. And the idea here, it is covering all dimensions of biodiversity. So we have genes, we have individuals, we have species, populations, we have communities. And other 2 features that are relevant for the EBVs is that they need to be sensitive to change. If we want to monitor biodiversity, if we want to track changes, we need variables that are sensitive to change. And they also need to have a spatial and temporal component. With this framework, I'm going back, sorry. With the EBVs framework, that was very far. So we have the EBVs framework. And now we are going to the other components for our FAIR approach. So we are working with data that is published at GBIF, that is following some data standards, mostly Darwin Core. And now what we want to do, we did actually in the project, was lowering the access barriers to big data. So with this, we deployed the species occurrence cubes. It was a workshop yesterday by Lisa, Martin, Andrew, Matthew. And in this workshop, we were operationalizing how these data cubes can facilitate big data analysis, especially that are published in GBIF, but it's not exclusively to GBIF data. If you were not there, I will just briefly say that we have a large documentation. I will not go in detail for that. We have a website dedicated to that. It's working since last year with Python and R wrappers, and basically what you have is an SQL query. So what you are doing there is setting, okay, I want to aggregate my data in taxonomy, so let's say families, species, genus. I want to aggregate my data in a temporal dimension, for example, months or years, and in that way, you can facilitate and download these data sets. In March this year, the friendly interface was launched. It is now hosted in GBIF, and for those that are familiar with the Species Occurrence Download Service website, now you have a new feature that is below, that is the tree number with the round circle, where you have this cube button. So whenever you select a species, I'm here selecting Speletia grandiflora, that is a species from the Paramo, it will aggregate the data. So this is how the species look in the field. It's from the Paramos ecosystem, endemic from the tropical America. And this is how the data will look like in a cube. It's a tabular data format that is aggregated. In this case, I did a criteria aggregation using time and space. So instead of downloading thousands of records. I just download 80 records with the number of species. For more information, you can go to this, you can scan these QR codes. You have information about the service. You have some tutorials. We have a dedicated website, and we are always happy to hear from you. You can reach us in GitHub easily, but we are also here, so feel free. To continue with this FAIR approach, we also have FAIR workflows and FAIR indicators. So all the code is available in GitHub. We also publish in Zenodo, and the geospatial data is published in the EBB data portal. Briefly, these biodiversity indicators have been calculated using different R packages. The R packages have been also developed for many of my colleagues. The pictures in the bottom is people that are here. Hanno and Xuan, the first two, they developed the data processing package for the B3GBI. Lisa and Quentin, they have been working in the phylogenetic indicator, and all this set of packages, it's called the B3verse, like the universe of the BQ packages. And something that is also very relevant to us, because this data is very diverse, is to calculate the uncertainty. So there is also a package that is called DubiCube for calculating this uncertainty. And finally, how we want to close this cycle of a better FAIR indicators approach is publishing data in an open and documented way. And in this case, we use the EBB data portal. This is hosted at my institute at IDIF. It was a poster yesterday by Christian. His picture is on top. And here the idea is we have a comprehensive metadata. So the data sets can be reproduced. You have an option to download the data set. You don't need an account for doing that. If you want to publish, you will need a GeoBond account that is free of charge. But if you just want to access the data and to play with it, you just need to browse and look for the portal. You also have metadata in a JSON file, and you have a visualizer if you want to explore the data before you download. So, just as a summary of my presentation, we are working with data that has been published in GBIF. You can, everybody has access to it. It's not limited to GBIF data. You can also use your own data. Everything is published in Zenodo and GitHub, and geospatial data is in GeoBond, EBB data portal. Everything is grounded in open data source formats and programs, and everything is having a DOI. So it can be tracked, it can be found. So in this way, we can also think that we can improve the way we are calculating indicators for informing policy. I want to thank you for your attention, and yeah, I'm happy to take questions.
Yes, I was curious about how this compares to Bone in a Box, because you're talking about EBBs and the indicators of the global framework, but I know Bone in a Box is using the same input data. Thank you.
Yeah, that's a very good question. I mean, the EBB data portal and Bone in a Box are both part of the GeoBond strategy for facilitating data analysis. Bone in a Box is a pipeline, so you are running the data analysis in Bone in a Box. What we do here is we are calculating indicators, and we are also in the process of moving some of the indicators workflows to Bone in a Box. It's in the plan, but we have not done it yet. But yeah, we are in contact with people from Bone in a Box. Yeah.
Thanks, Lena. So I just want to check, is Verena in the room? Or, okay, no. So we do have a video from Verena. So we have Verena Schreimeyer next from DHI Denmark. This will be a video. Is she online? Can I? Is she online? Yeah.
Hello everyone, greetings from Denmark. I'm sad to not be in Bogota, but unfortunately I couldn't be there today. Today I would like to tell you about our biodiversity state indicator that we have developed in-house and how we can capture biodiversity with an ecosystem-based approach. I would like to tell you how we see that this can make a big difference, and especially with the Kunming-Montreal Global Biodiversity Framework in place since 2022, a lot of countries have filed their NBSAPs, and there's a lot of actions on the way to halt and reverse biodiversity loss by 2030. What I will present to you today had very much at heart to bend the curve, as you can see here. How can biodiversity sustainably be used and maintained? How can we halt extinction, restore the natural ecosystems? For this, we can feel that there is a need for having more tools that we can align on. We are out there and having a lot of kind of actions that are going on in the industry. There's a lot of impacts driven through the industry sector and how we are acting in the marine environment. Different pressures are going, different kind of headaches are going on, and different kind of ways how we can assess biodiversity is really what is going on. But then there is this gigantic elephant underwater, because what we really need is to come to a place where we need to align on how we understand and quantify biodiversity. Only then we can really see a change and can create a change. So how we saw nature so far, we can see a lot of different things, and we have the taxonomic diversity, which is very much in our focus on how we describe biodiversity. And some of you might picture here, there is actually an pineapple hidden. And these kind of features on who is actually there and what do they do, that's something that's then overlooked if we only go for taxonomic diversity. The BSI, the Biodiversity State Indicator, has 3 different levels. It accounts for the taxonomic diversity, it has the functional diversity, but also the ecological interactions. It can be understood as a compound metric because in each of these 3 kind of pillars that we call them in our compound metric, we actually allow for having very standard ecological statistics. But the way we compile and then also align or normalize them is a new way so that we can reach a point that we have a very compelling way of how you can compute and communicate in the end the biodiversity status. Guidelines on biodiversity assessment and reporting are out there, and the same principles are being postulated throughout. Ecosystem functioning, resilience, ecosystem services, interactions, competitions, these kind of aspects should really be considered. And these were therefore the guiding concept for conceptualizing the biodiversity state indicator that we have developed. So this is what it is. It is really a performance indicator. You can use it because you can relate it to a desired state, a desired location, a desired time point. So you can compare and thereby resolve the net positive or the net trajectory. Maybe it goes negative, but where is your status compared to a certain status? What can you do with this? Here we have a North Sea example, naturally coming from Denmark. This is where we are. So we have different kind of operators that you can see here in the little tiny insert. You can see where we are in the world. And in the kind of blow up, you can see here that there's the North Sea. All these different kinds of colored fields, different types of operators that you can see up here. In green, you can see oil. In red, you can see gas. And there's a lot of operations that are going on. So what we can do here is we go out and measure the seabed in fauna. So we've been doing that for our clients for more than 30 years. So we have a very big and large data set that we got to play with and apply our indicators. And here you can see this is actually a standardized BSI at 0. This is our reference conditions. In this kind of monitoring, you had actually a geo-referenced reference station, so most pristine site that we could have. Then you can see here on the bottom on the x-axis the timeline. So 2006 we started, and then we're toggling up to 2018. And you can see there's a good trajectory towards reference conditions. On this path here, throughout time, we had a lot of operational changes. We definitely did play a big role in advising on how can things be done, maybe operational changes through new law giving. That's all possible how we come to this place now. But it definitely take a difference. So in terms of biodiversity status, we're reaching reference conditions. That's perfect. But some of you might be really like, okay, what is this BSI about and why would we even consider this? So for that is actually quite interesting if we then look into these individual computations for each of the years that were monitored. You can see the taxonomic diversity on the top, the functional one in the middle, and the interactions below. And you can see that there's been actually a big drop in 2016 in the taxonomic diversity. By only considering our traditional way how we look at biodiversity, you would have thought, okay, my system is really struggling, something is going on, and something was indeed going on. But this is not the topic of today. But the point is that the functional diversity really jumped up, as you can see here in this individual computation display. And so that means there's been some opportunistic species that obviously took place and overtook the roles that still then accounted for that the system and the biodiversity itself is functioning. And this functional aspect is something that can really make a difference by applying a BSI. And if we then want to spin it a bit further, then you go to a place where you do the monitoring right there on site. But you also want to have a good site overview. This is especially important for NBSEPs. How can we see over the whole area? How are we? Just because we do a good monitoring program in my very close proximity at my operational sites or where there's been a good research study, we want to see this kind of overview that we can see here. This is the North Sea just in front of the border of, you can see here Germany, and up here is Denmark. And you can see here the BSI toggling from neutral, which is white, the negative is the green, and the brown end is sort of the positive, the net positive aspects. And you can see that here are different kind of activations and different fields of industry and offshore industry. And here is towards the coastline, you can see there's quite a lot of improvement in the biodiversity state indicators. Towards the more western side of the North Sea, you're still sitting a little bit more on the lower end and not really comparing to reference conditions. So there is some of the southeast gradient, and those are the major current directions that you would find here. So there is something that is going on with these kind of industry activities that clearly affect the North Sea and this type of area that we're looking at here. So this can inform where should we put, for example, marine parks, where can we do maybe very limited industry activities. There's a lot of information that we can then use for underpinning different types of management, and in this case really ecosystem-based management approaches. For a coastal example, where we have here with the circles that have a round, a black circle around, there we have actual samples that were taken and they served as input for the biodiversity status. With our model predictions, we can then get to this aerial footprint overview as I showed you on the other side, on the other slide. And with the predicting variables that we can then get out of our model and have as an output, we can see whether it's the salinity, the oxygen, or what part of the physical conditions that we have as input to our model drive our biodiversity. And how does it look in close proximity to my coastline? Does my new restoration site? Does it make a difference? How far is the positive impact reaching? It's not just about negative impacts, it's also about the positive impacts these times. So our vision for 2030 is we can really guarantee that this is an informed decision making by using the biodiversity status indicator. The aerial overview of biodiversity and ecological status can be given. The restoration support tool, this is really what it can do, and it can be used as input to other ecological modeling tools. And it is an alignment between different industry sectors. How can we report on biodiversity status in alignment and gain this aerial overview? So thank you for your attention, and please by no means reach out if you have any questions. This QR code will follow me on LinkedIn. Thank you very much.
So thank you, Verena. Unfortunately, in the interest of time, we're going to have to move on to the next presentation. But if you have any questions, please follow up with Verena. So we're going to move on to Ana Valenzuela Toro from CIH in Atacama.
Good morning, everyone. So I'm going to take a different time perspective here, and I'm going to talk about fossil biodiversity. And just I wanted to start saying that paleontology is not only about the past. It also is important because it gives us perspective about how life and environment have changed over time. But also it provides a new dimension and a context for how modern and current biodiversity is changing, is trending, and also give us some predictions about how it will change in the future. So when we are talking about fossil data and how it's represented in international infrastructure, we can see that paleontological data or fossil data is not evenly represented across the globe. So this is just fossil occurrences recorded in GBF. And we can see there is a bias toward data, paleontological data from the global north. So there's data here for the global south. But interesting, at least for Latin America, most of the data that is recorded in GBF, it comes from collections that are housed in museums and other institutions in the global north. But basically, we are seeing data from the southern hemisphere, but is stored in the global north. So this is really interesting because the global south, and here I'm referring just for data from Latin America, has very rich fossil collections have changed over the last few years, or conception or ideas of how past biodiversity worked, right? But we don't know, I mean, the international infrastructure, data infrastructure, they don't capture that. So I'm going to explore two study cases that, based on Chile, that have been devoted to understand better how we manage paleontological data in general. So I'm going to start with the first case. This is a site that is known as Cerro Ballena. This is a very spectacular example because this site was discovered, or I will say that it's not discovered, but it was uncovered during the expansion of the Pan American Highway that you can see here, very close to the city that is right over there. And here we found like dozens of fossil skeletons of whales, like we see here, and they were like 40, and other vertebrates. And what is interesting is that we were running against time because this discovery, as I say, was made during the construction work. So we needed to rush to collect the data before the site was lost. So what we did, we created a partnership with other scientists. I was an undergrad at that time. I'm talking about like 2012. And so we partnered with other scientists from the Smithsonian, especially. And we collected a lot of data, but what was more remarkable is that we developed a system to 3D scan the whole site. And the site doesn't exist anymore, so now the route is just over here. and the wells we excavated the well and we moved it to a facility nearby. But the digital data allows us to have the site digitally, and we have a full resolution of the whole site. It is very spectacular. And so this example is, to me, provided. Have a lot of contributions in general, not only for the Chilean paleontology, but also for the paleontology in general, because it demonstrated that partnership and trust between Chilean and international teams, but also the involvement of non-traditional actors as construction and industry-based stakeholders, and also the government, allow us to also innovate and develop 3D new techniques like 3D scanning. We are talking about more than 10 years ago. So the scanning technology didn't exist as it exists today, and that allowed us to have a rich documentation. But again, we are facing problems like data is fragmented, and also highlighted that we need several needs for long-term preservation. And the second example I will give you is that the previous case was based on a project-centered data management, but here in my institution, in Atacama, we are taking a different and more regional perspective. Is that the Atacama in the north of Chile, it's known by its abundant, diverse, and well-preserved fossil deposits, but most of the data is not represented in international data infrastructure. So what we did here, mostly Martin is over there, he led a team that they conducted the first systematic overview of the paleontological information, and they wanted to understand how paleontological data is generated, curated, and managed. And for that, we not only focus on research, but also in other non-traditional data sources as geological maps, but also industry. So we not only recorded our contact fossils, it's still more than 3,000 fossil occurrences just for the region, but they were able to create very accurate maps and define hotspots where the fossils are. They created a baseline to understand how dynamic is where they are, those fossils, and that allowed us to prioritize digitalization and bring the bridge between policy and conservation. And the results of that is not only the data itself that is now collected, but also we are working on, this is soon to be published, a book devoted for the general public, but also several of infographics based on the data, data centered. And if you say at the end of the session, we have some posters for you if you are interested in having them. And finally, inspiring those examples, those study cases, we are developing a new framework for the paleontological data management that is basically based on the idea that depending on the context that you are, if you are industry-based or research-based working paleontology, you will have different types of, you will prioritize different storage type. You will have different users, users are not only scientists, and also different beneficiaries. They are very, very diverse. And depending on what you are doing, if you are industry or research-based, etc., the different actors or stakeholders will prioritize some connections versus others. So this is just an example, the landscape, the data landscape for industry. And finally, to close on my presentation, is that in my institution, we are a private public institution. So we are the building right now, this new center, paleontological centers will be open next year. And that will focus on centralize, curate, and preserve the Atacama fossil data that will bridge the local efforts with international biodiversity infrastructure. That is our goal. And we are not only taking over from the fossil collection, it's the largest fossil collection from the region, but also we are gonna interested in connecting the data, as we did with the previous example, between research, industry, or environmental impact assessments, and create partnership with different agencies. So if this is something that you are interested, please reach out to me because we are not trying to create the wheel. We really want to learn from others' experiences. And with that, I want to thank all the people that supported us and inspired. We are having a conversation that inspired us. And this is just a fun way. This is our, some artwork that local people in Atacama have been created based on the fossil record of the region. So this is a community-based effort. And it shows us how important it is for the people to know and understand the data that they have. So thank you so much. Yes.
Thanks, Anna. So that was a nice example there demonstrating how different partners are working together to meet data needs at a regional level. Time for one quick question if there's no time. No, I'm being told. Okay, we'll move on to the next presentation then. So the next presentation will be from Yvan Lebrun from the National Museum of Natural History in Paris.
So, hello everyone. I will try to do my best to speak in English, not so bad, and to understand you if you ask questions. I have 26 slides, so I think it can be a little bit complicated, but I will try to do. First question, why do you think internet why internet? Oh! I don't know where. Something like that. Why is internet a success? If I ask a question, it's because, in fact, if we want to achieve the goal we need to achieve in biodiversity monitoring, we need to have something which is really fair in terms of, or high degree of fairness in terms of data, workflows, source code, and things like that. So taking the example of internet can be something maybe of interest. So anyone try something? 25 slide. Someone, please. Because it's free. Well, yeah. Oh. Okay. So I will go quite quickly. Because of HTTP. Wow. Because in fact, we can see a lot of things and bad things now we can see in internet. But if internet is a success in the term of everyone can access and use it in the world, something which is related to what we need to achieve the goals regarding biodiversity, data, access, and source codes, access to compute indicators and things like that. If internet is a success, it's because everyone in the world at the moment, private company, public company, any kind of countries, have said, okay, I can use a protocol, a shared protocol. Here, HTTP, for example. So there is an initiative called GoFair, who is there to create an internet of fair data and services for research, for supporting research practices. And the idea of GoFair is to look at this idea and look at the protocols or standards we can use to allow to give unlimited services and data to an unlimited number of users and contributors. So that's why there is this hourglass images. And the idea is to use the existing tools and standards. And in biodiversity, we are leading with Anne-Sophie Archambault from JB France, the initiative to create this Internet of Fair Data and Services for biodiversity called Biodiversity. So this is what we call an implementation network, where we give some guidance on practical ways to achieve this goal. This goal is quite simple, because we are just reusing existing tools, protocols, standards, and things like that, and communities. On one side, on analysis, we based on the Galaxy project, which is 20 years old, who is used by hundreds of thousands users just in Europe, the same in US, the same in Australia, connected to high performance computing and things like that, with big communities of contributors. And on data, one main thing, metadata and ecological metadata language. EML is 28 years old. But this standard is amazing. You can describe really precisely your data. You can describe and use semantic annotation. You can create JSON-LD manner of metadata, so you can use a web of the Internet of Objects or things like that, or semantic webs to interrogate metadata. So just with that, we can create something, a good basis for Internet of Fair Data and Services for biodiversity. Linked to that, we are leading an EBV operational pilot where we try to operationalize the use of Galaxy and EML so we can apply it to any kind of data and source code to produce metrics and indicators in biodiversity. To go rapidly, what we need to support KMGBF, representativeness, sensitivity, comparability, integration. This is a part of something which is behind essential biodiversity variables. But we need also accessibility, automation, reproducibility, and rigor, which is something we can find, for example, in this beautiful description of what can be an EBV workflow from Quisling, where interestingly they are speaking about what we need is an open source and freely available service in a workflow-oriented infrastructure that support curation, sharing, and collaboration. We already have it, in fact. With Galaxy project, with at the origin more for life sciences, we can build this kind of things and have accessibility, automation, and reproducibility. So Galaxy for the analysis of data and production of EBV computational workflow is really something we can use to have accessibility, reproducibility, transparency, and peer review. And just quite briefly, what is a Galaxy tool? This is just switching from a script, R, Python, any kind of language, to a form that someone can reuse to execute the code and have results. Wow, 2 minutes and 18 slides. Another thing that is really interesting, if you go to Galaxy Europe and notably the Galaxy Ecology instance I am leading, we see that what called Sabina Leonelli yesterday, around the importance to track data provenance, data processing, supporting knowledge, and we need to have tools who allow us to go very far and not very fast. We have that. This is exactly the backbone of Galaxy. We have traceability of each data provenance, each processing steps, each workflow execution, and also access to the code who are all open sources and accessible. So to go rapidly, we just published this year, after 7-year works around the Galaxy Ecology Initiative, this paper describing the idea of the work we have done, and briefly it's to go towards the atomization, generalization framework to take any kind of script or workflow we can allow to produce metrics, biodiversity metrics, and to see how we can generalize it so we can reuse it in another context in terms of taxonomy, geography, or temporality. And we apply this on several kinds of data, notably data who can be heterogeneous. Biodiversity data are heterogeneous, so we don't need to have one format to describe all the biodiversity. It will never work. So we have to deal with the heterogeneity of data and the heterogeneity also of manner to describe primary variables we can use in workflows to produce metrics. And this is something we can do. We make a lot of tests. We have several workflows who are allowing this. And as an example, the last work we are doing for conservation in Antarctica is, for example, to produce an EBV workflow on Galaxy to produce ecoregions from data, marine data and invertebrates. And we can reuse it just to try to make the same things on vertebrate species on Atlantica. And we can see that there is a parameters you can use for environmental data. You just have to select the parameter to redo the same execution, but changing the scenario. This is so 3 clicks. You can try it. We have the same workflow to use it. If you want to know more, don't hesitate to look at the tutorials we are creating, and the beautiful tutorials to look at EBV data portal visualization, EBV data cube visualization into Galaxy, notably. And I will go really rapidly. Just breaking news from this morning for a Dynamo project for Biodiversity Plus. We are working on producing workflows to produce genetic indicators. This morning, Laura just presented me the result of what she is doing for any N500 indicators. So it's really something with interesting. So we can have things on Sentinel data for remote sensing. And
I really want to thank all the young guys who helped me since 7 years to try developing all these magic galaxy things for you all guys. And sorry to be quite late, I think.
Okay, so we are just at time, I think. We'll move on to the next presentation. This is from Alex Killian from the Yale Center for Biodiversity and Global Change.
Andrew, you're running a tight ship here. I appreciate it. Yeah. I have 4 videos, though, so this is a different kind of pace, maybe, yeah? Is this mic okay? I hope it's going good. Yeah, thanks, Andrew, and for the organizers. I really appreciate it. I'm Alex Killian. I'm the Managing Director at the Yale Center for Biodiversity and Global Change. One of our key initiatives is the Map of Life. I'm talking today mostly about a new program that we have that's more tailored towards national governments. An important piece. Yeah. Yeah. Okay, so Map of Life, if you're not familiar with it, MOL.org. We aggregate all sorts of biodiversity information, species data, environmental data, trait-based data. We package that up into essential biodiversity variables. So we have 3 indicators that have been adopted by the Global Biodiversity Framework. They're species-based, and then we put this online to make it interactable. So then quickly, oh, and there's sound, there's nature. We get a little bit of nature in here. I wasn't expecting that. So this is Map of Life, if you're not familiar with it. So you can generate species lists, interact with different kind of country portfolios of that data, looking into then these different indices, tracking progress over time, species kind of distributions within those countries, and then showing actual species data, so all the GBIF data, occurrence data, range data, and then tracking habitat as well, so integrating this then with remote sensing data at a global scale, looking at connectivity over time, and then also doing species distribution models, and so doing these at high resolutions that are relevant for local decision making, and so doing this kind of on a continental by continental project way, but then also scaling this up to more global patterns, right? And so tracking biodiversity trends at that global scale. So this is all freely available. MOL.org, you can access it. We've recently done kind of a facelift. It looks a little bit better than it has in the past. But so, right, that's a public repository, and that doesn't always serve national government needs very well. So I'm going to pivot here a little bit now and talk about a case study of Guyana. So Guyana is a country that has rich biodiversity. They've also recently made some very ambitious targets, 30 by 30 goals, but also more recently a comprehensive national monitoring plan, so setting kind of a wall-to-wall baseline and then doing repeat sampling for the next 5 years. And so this is coming from the president's office. So this is President Ali himself with our team, and so he has like his hands in this. He's making it a national priority, which is great to see, and I think is setting an example for many other governments to do this. But right, governments are often lacking the data infrastructures to do national monitoring and doing it in a very kind of fast way to hit these national targets. And so we've been working with them to and many other countries to kind of establish data management systems that allow them to achieve this in the time frame that's necessary. And so what's kind of particular about national data or government needs, right? It needs to be in a secure cloud-based system, but also have a local copy. They need to then be ingesting data from other local partners, international researchers, like all the activities that's happening within the country. And then that needs to be standardized, right? It needs to be based on some sort of taxonomic backbones. This is where we pull in the Map of Life data, making sure that it's all standardized, and that this is maintained, right, over and updated basically on a monthly basis. So this is an example of kind of just a tiny, actually, representation of all the different agencies and NGOs, local community groups, indigenous groups, universities that are working in the country to select or to collect biodiversity information. We then have all of this Map of Life and just other global data, remote sensing data that needs to be integrated with this. So this is about building ingestion pipelines, standardizing data across the country, and then, but anticipating then the volume of conservation technology data and like what the standardization challenges that this brings, also the massive volume that they need to anticipate ingesting and doing this with systems that kind of can load this in real time. So giving you a very, very rough structure here of what this kind of data management system looks like. It's built using Esri technology, so most governments already are using Esri technology and trusting them for other department needs in the different agencies. So that has really good security, administrative access, all these different things, but also allowing them to then do additional GIS analyses when that data is in there to begin with. So we create a national government kind of account. So this is an Esri database. The agencies then can interact with that in different ways. We then create a separate account, a different database, where we develop a consortium of all the other NGOs or community members that are working in that organization, where they can upload the data, and we have data agreements to where this is kind of view only. So everybody here is retaining data ownership and data sovereignty, but it allows it all to come together and be viewed in one place. So then the addition then, so it's kind of all the nationally kind of local data collection. We then feed in all of our map of life data, so they have access to large volumes of information. We're constantly updating that. And then it's viewed, right, on the front end. It all comes together in what we're calling the NBIS, the National Biodiversity Information System. So in the back end, it's all different databases. You retain data ownership, but then it at least all comes together so you can view it in one place. So of course, then you have, using the Esri ecosystem, you have different settings, administrative access, things like that. I have 2 minutes, so we're going to start looking at some videos. So this is then what the interface looks like. I think this is going to go now. OK, yeah, so we're moving. So this is the kind of the front-end interface where the data comes together. We have different ways to interact with this data. So they have protected area layers. They have their administrative units. They have maybe areas of interest. We also then can load in all the different, so this is like field museum data. So this can all be viewed in one place. This is meant to then generate species lists based on these predefined areas, or you could select a custom area. There's also then other data layers that we can show. So we also then have all our STM data. So for example, other administrative type data. This is indigenous territories, species richness, species rarity. So these are some preliminary results of our aggregate patterns that we can feed into the system. So lots of them, ants, butterflies. So we're trying to get broad taxonomic representation. So this is a lot of the science that we do at our center and feeding this in there. So then you can interact with this. And so this would be, so this is a protected area. You get your expected species lists. You can filter those based on the sources. Were they prediction-based? Were they occurrence-based? Different threat statuses. You can then interact and then query the different species. So I think we're going to look at one here. So then we start to actually look at the individual species data, right? So here are habitat suitable ranges. We have SDMs in here. You have the point observations. These ones are coming from GBIF. They also then would separate out their private data so they could know what was collected by who and when. We're tracking habitat loss over time in this graph. So this one doesn't have a large, it's good to see not a huge decline in habitat loss for this species. But then we're starting to get on these EBVs, these species-based indicators, where we're tracking how well are we protecting the species over time, how is Guyana doing it versus their neighboring countries, what is their stewardship responsibility. We're also then tracking habitat loss and connectivity over time, and as well then comparing this to nearby areas. So here, Guyana doing better than Venezuela or Brazil, but they have been lacking in conservation for this particular species. That's it. So that's more of a species level view. The last one I'm going to show here then is kind of more at the ministry level, so at the kind of the top level of decision making. So here we're showing some of our indicators at aggregated form, the species protection index. So lighter colors are indicating places that are doing a better job of conserving species based on their protected area networks. We can then see that distribution of individual species scores. So how well are these different taxonomic groups and then individual species being protected in each of these regions, so we can start to prioritize the types of conservation or the types of interventions in the different regions that they have kind of like make decisions at, right, at this state level. This is all then downloadable in more kind of tabular table formats. Then the same sort of thing then looking across some of these other indicators, the same thing with habitat loss. So looking at where the region's starting to kind of get a priority or a prioritization of areas where they need to be tracking forest degradation a little bit better. We're also then kind of highlighting and drawing in the species that are of most concern, so then you can link to that species data. You can actually look at the trends on a species by species level. And then lastly, this is kind of like monitoring efforts. So this is our last indicator. So where are you collecting data? Where are you getting good representation across different taxonomic and species groups? And so here, of course, like near the capital, you're getting lots of data coverage, but then in areas farther in the south, there needs to be more monitoring. Okay, so I think that was like maybe just at time. So this was a focus on national governments. Obviously, the same system can apply at a landscape level anywhere where you have multiple organizations coming together that want to keep data sovereignty, but still allow all the information to live in one place to coordinate activities and meet their goals. So thank you very much. In my butt, yeah.
Great, thanks, Alex. Yeah, unfortunately, we are running a little bit over time, so we'll move on with the next presentation. So we have Catherine Jardine from Birds Canada. So if you
Okay, so as he said, I'm Catherine Jardine. I'm from Birds Canada, and so today I'm going to talk to you about our Nature Counts platform and how it's being used to support the Global Biodiversity Framework in Canada. So I don't really need to tell this group about Targets 20 and 21. We're all familiar. This conference has really demonstrated the work that's being done at the global level to support these targets. I'm hoping to zoom in and talk about some of the tools Birds Canada has been developing to support this framework at the Canadian level. And so one of the ways we're doing that is through our Nature Counts platform. So this is Birds Canada's open data tool. It consists of a set of tools to help people collect and interpret and then share biodiversity data. This is for both citizen scientists and research data. And so I'd like to start with the collection aspect. For us, open data really starts with collection. And so one of the major blockers we saw for projects when it came to meeting fair abiding principles was the need to standardize and upload their data. So we've built the Nature Counts mobile app, which offers customizable data collection for research and citizen science programs. So it pretty much supports any observer-based monitoring protocol with an emphasis on bird monitoring, but other taxa too, and particularly for things like point counts. One of the questions is why not use eBird, and the fact is we do. So the Nature Counts app is tied to the eBird API, so we're able to collect additional covariance, more fine scale or detailed data, while still moving that checklist data into the eBird portal. And so the app provides a benefit to programs, particularly in terms of cost savings and user experience, which also incentivize adoption. And what we've seen is that with this, data is incorporated into a FAIR repo the moment it is collected, and that's reducing time between it's being used and it's being collected. And we've seen increasing, almost like overwhelming adoption of the Nature Counts app by various citizen science projects, and that's beginning to expand. And with that, the data flows into the Nature Counts database. And it's joined with other external databases forming a resource, which at 360 million records now, I think we're the largest biodiversity database in Canada. And for there, it powers both decision support tools and data sharing. And of course, the next question is why not just use GBIF, right? Which is the great question. And the reason is that not all the data sets in Nature Counts are governed by a CC BY license. Some because it's not appropriate, either because of indigenous data sovereignty or sensitive species, projects on private lands, and some because the data owners have simply not agreed to do that yet, right? At least we have the data even if we're not able to share it with GBIF yet. we have a data platform that has 6 different data access levels. Some let us push the data to GBIF, and others let us incorporate it into decision support tools, even without sharing the raw data. And that's the important part, because this database is increasingly used for a conservation application in Canada. So a variety of interpreted data products support decisions, including maps, and interpretive population trends. We have about 63,000 different trends from 24 programs that have been incorporated, and publicly accessible reports like the State of Canada's birds, and species accounts, which we've tied directly into the Canadian government's nature indicators. So sharing happens through these public decision support tools, or raw data sharing, or workflows tied to the Nature Counts database. So the raw data is available for query and download, and a dedicated R packet. Ooh, what has happened? I swear I only hit it once. Don't look, spoilers. Okay, the raw data is available through a Nature Counts R package to be pulled directly into workflows and analysis. And we've got about 30,000 registered users, which is a lot for Canada. I'll defend that. And we get about 11,000 data requests each year. And that's used for impact assessment, land use planning, research, lots more. And one of the things with this is this balance of open and secure. So our data access level 3 lets us control access. So users can come to our platform, request data. That request is sent to the data owner. The data owner logs in, approves or denies the request. The system automatically packages it and sends it to the requester. So that lets us make the data findable, interoperable, and reusable, but leaves the accessibility in the hands of the data owner, which helps support principles like care. And so we have a process tying data collection straight through to decision making, all within the one platform. And so this directly supports Target 20 and Target 21, right? But of course, those are only 2 of GBIF's targets. And I'd like to take a moment to zoom in on this conservation process workflows, because these are some interesting and repeatable ways the data has been leveraged now that it's in this accessible repo. And so I'm just going to go over highlight 3. Well, can I have my presentation back? It's all great. It's good. You want to just take me to the last slide? In review, next. Okay, I want to highlight 3. So 1 is a dedicated workflow using the data in the Canadian process to identify endangered species. So this is the Committee for Status of Endangered Wildlife in Canada. This used to be a manual process. They've tied directly into our database and are using this to help identify species that need to be listed under our Species at Risk Act. This is supporting Target 4 of GBIF using this database. We also have a tool to set and evaluate federal population goals for Canada's birds under the Migratory Bird Convention Act. So that's taking the database, working with our government partners, and tying the data directly to their outputs. So this is supporting Target 14, integrating biodiversity data into decision making by partnering with governments directly in our portal. And then we also have a dedicated workflow bringing this data into Canada's key biodiversity area process. So this is supporting Target 3 of protecting lands, where these projects pull the data from Nature Counts, and they estimate about 90% of the data used to identify key biodiversity areas for birds in Canada came from the Nature Counts database. So all of this is to say that by supporting the FAIR-enabled data collection through the Nature Counts app and bringing the data together with more fine-scale permission management so that it can be incorporated into these decision support tools, we're helping connect the data that's in Nature Counts directly to the targets of the Global Biodiversity Framework. So while this was built for Canada, one of the reasons I'm here is because we've increasingly received interest in these tools, particularly the app, from international projects. And so I'm keen to learn how we can fit into the broader data landscape and share these local tools where it makes sense. So you're welcome to come and chat with me or check out the platform using this QR code. I also have some postcards if you're interested in talking about how this might apply outside of Canada.
Any questions?
I did a very good job. They all get it.
And we are now on time. I want all of this to as well afterwards, just so that people can come and ask questions afterwards. Okay, so we will move on to our next presenter. So we have Cédric Elboud from Biotope.
So good morning, everyone. I'm Cédric Elbaud from Biotop. I'm a biodiversity consultant. I'm from France. And today I will make a presentation to explain how biodiversity consultancies could play a role in achieving KMGBF objectives, especially by sharing biodiversity data. So first, I would like to say a few words about Biotop and also explain how consultancies collect biodiversity data. So Biotop is a 32 years old company. It's specializing in biodiversity and ecosystems. And now Biotop employs more than 500 employees, and it operates worldwide. We have an office in Colombia now. And our clients are either public institutions, NGOs, or private companies operating in various sectors. And within all our services, some services generate primary biodiversity data. So we have many employees going in the field collecting fauna and flora observation, especially within the baseline studies and biodiversity monitoring performed within environmental impact assessment and biodiversity management plan for specific areas or species. So each year, Biotop teams collect a growing number of species occurrences in the field. And in 2024, we reach 10 million of species occurrences over the world. So now I would like to try to demonstrate why this data collected by consultancies have a particular value. In 2019, we made a study for the French Development Agency, AFD, and within this study, we demonstrated that if all data collected within environmental impact assessment funded by AFD was published, it could reduce the gap in biodiversity data in data poor countries, especially in Africa and Asia. For instance, a project funded by AFD could alone provide up to 15% of the data published annually on JBIF in Africa. And what is interesting also in data produced by consultants is that it covers some understudied ecosystem. For instance, we get a lot of data in marine ecosystems. So what I can say also why our data are quite interesting, it's because we collect a lot of data for understudied biological groups. So on this pie chart, you have an example of the data collected by Biotop. So you can see that a lot of our data are related to bats, 70%. And if we compare it to the JBIF data, in JBIF we have less than 1% of bat observation. So this kind of data can be very interesting. Our data collected, I would say data collected by consultants are also interesting because most of them are collected within standardized protocol, and it's not opportunistic observation. So, for instance, in Biotop, we estimate that more than 95% of species occurrences are collected within sampling events or standardized protocols. Another reason why we think our data are valuable is because it's collected by high qualified people, especially professional naturalists, but we have also people specialized for managing data, such as GIS experts. And in Biotop, for instance, we have put in place specific recruiting process, and we have a strong emphasis on employee training. In Biotop, we have also developed a specific internal tool to collect and manage biodiversity data. So this application is named Shuriken, and it's made of one mobile app and a desktop app. So the mobile app allows us to collect offline the data in the field, fauna and flora observation offline. And with the desktop app, we can manage the data. We can also import data coming from sensors and then export the data in a variety of formats, for instance, for data publication. And within our application, we can collect many metadata for the survey and the species occurrences. I go fast. And all our data are geolocated within the digital tablet we use in the field. So with the GPS or directly located on a map. To name the species, we use directly the most updated taxonomic reference systems, such as the GBIF backbone taxonomy or TaxRef in France. And we produce also regional checklist of potential species to avoid a mistake in naming the species. To conclude my presentation, I would like to say that up to now, most of the data collected by consultants remain inaccessible, but things are changing. So why it was or it is still quite inaccessible? It's because the data collected by consultants are co-owned by the consultant, but also by the clients of the consultant. So we need the agreement of the client to publish the data. But in line with the KMGBF objectives, several initiatives encourage consultancies clients to publish the data acquired through their funding. For instance, at the international level, we have two initiatives, the Data for Nature initiative and Equator Principles. So these initiatives are led by financial institutions, and they encourage their clients to publish the data. And for instance, at the national level, we start to have a regulation requiring project developers to publish the data acquired within environmental impact assessment. So we have it, for instance, in France, in Colombia, in Norway. And we have also voluntary initiative at the organizations level. For instance, within the ESG reporting, more and more companies have a volunteer publishing of the data. Thank you for your attention. And I hope I am fine.
Do you have any questions? Do you have time for some questions? Oh, we've got a couple.
Thank you. I'm just curious about how the data governance is according with indigenous peoples and local communities. How do you work that with the governance of the data? And also, you said the intention is to grow in sharing the data in bigger platforms and open data platforms. How much is that happening, not only for you as Biotop, but how much do you think is happening in the consultancy?
So for the question related to indigenous community, I would say I have no answer because I'm not directly involved in this study, so I should ask my colleagues. But for the second question, I would say we are just at the beginning because not many consultants have shared their data because they need frameworks, we need regulation to for our client to ask us to publish the data. So I would say many consultants are still discovering GBIF, and they don't know how to publish the data on the GBIF. And I hope it will progress in coming years.
Okay, we're going to have to move on to the next one, but you'll be around for questions, okay? Okay, so we're going to move on to our final presentation from Reem Almiala from Nuance.
Okay, hello everyone. I'm very conscious I'm between you and lunch, so I'm going to try and make sure that this goes as smoothly and as quickly as possible. So my name is Reem Almiala, and I'm here on behalf of also my colleague Nick Pyson, who couldn't be here today, from the Smithsonian Institute Natural History Museum in Washington, D.C. So I'm going to be talking to you about cultivating Gulf biodiversity data sharing in low trust environments, because if we don't trust each other, how can we share? That's the question. So, no? Okay, perfect, thank you. So, I'm going to be talking to you today from the other side of the world, so put on your seatbelts as we fly through to the Persian-Arabian Gulf, also known as the Rukmi Sea Area, and I will soon tell you why we call it the Rukmi Sea Area. If you don't know where that is, it is in the Middle East, and basically if you zoom in, it is where Saudi Arabia is on the western side, Iran is on the eastern side, and then it's surrounded by the rest of the countries like the UAE, Qatar, Bahrain, Iraq, Kuwait, and Oman. So what most people don't know, other than the fact that we're always on the news because of conflict, oil, and money, is actually we're situated in the hottest sea on the planet. So the question you might be asking is, what is hot, right? It's all relative. What's hot to me might be cold to you, and vice versa. So to put things into little context, during the summer, air temperatures go up to 50 degrees Celsius, okay, and during the winter, it can go down as low as to 5 degrees Celsius, okay? So very big fluctuation. In terms of the waters, sea surface temperatures, waters go up to 36 degrees Celsius, and in the winter, it goes down to 16 degrees. So we live life in the extreme. It's extreme in every single life possible. So the thing is, do we know much about biodiversity there? Most people have an idea of what does Arabia look like. Camels, sand, anything else comes to mind? Not much, right? However, because conservation is uniquely complicated, and as we know, nature has no boundaries. Everything just moves around, right? But we, as humans, love boundaries. We love borders. We love to be like, that's my space, please don't step into it, right? But also, there's anthropogenic pressures and many other things that all come underneath this conservation space that we're talking about. However, without data, without infrastructure that's adequate to be able to actually facilitate this data, with limited data sharing, how can we really even talk about conservation? So, I'm here to tell you we're more than oil, money, desert, and camels, okay? So, in the hottest sea on the planet, we actually are home to the largest aggregation of dugongs in the world. We're also home to the largest concentration of dugongs in the world. 5 minutes? Really? Okay. And so we've got so many other ecosystems like coral reefs, seagrass beds, mangroves, and in addition to other things. However, is this even represented in international platforms? Of course not. If we look at GBIF and OBIS, we represent less than 0.1% of the global data. Isn't that crazy? So, there's many challenges. I mean, these challenges have been discussed in every single room over here in the last 2 days, right? And it will continue, and it'll be the same thing. So I'm not going to be repeating this. However, what I really want to really point out when I talk about low trust issues is the political situation where it is so geopolitically complex to an extent that data is a strategic asset, okay? We have an issue with the naming. So as a scientist, I am not allowed to publish a paper other than using the name of Arabian Gulf. My Persian colleagues are not allowed to publish with using our name, because they don't consider it the Arabian Gulf, we don't consider it the Persian Gulf, okay? And so whatever we publish will no longer be standardized. It'll be different. So you will never find our data, you'll never find their data, and then everything is just lost, okay? It's that weird and that strange. So, and also, in terms of scientific and technical, you'll find data in terms of, it'll be in Arabic, it'll be in Persian, it'll be in English. Where do you even start? So, we are here to talk about mycelium because we learn from nature, right? We humans need to learn from nature because we forget that we are nature. It's that quite comical. Okay, so why mycelium? Mycelium is invisible. It works underground. It is not centralized. We're so obsessed with being centralized. Everything needs to be centralized because we don't trust anyone, right? But decentralization also works. Why? Because decentralizing things is bottom up rather than top bottom. So the principles of mycelium look at decentralization, looking at multiple hubs of data. It works in terms of reciprocity, so give and take, okay, whilst ensuring equitable value exchange. And it's quite resilient and adaptive. And we've been doing this for centuries, by the way. It is not new. So, regional case studies, there are many due to lack of time. I'll only talk about one, which is the GCRMN, which stands for the Global Coral Reef Monitoring Network. So they started a few years ago, this initiative. It started a long time, took a break, like most scientific reports, right? And then they said, okay, we need to know what the status of coral reefs around the world is. And so they were like, where's the data from the Rope Sea area? Okay, nobody had data. People who had data didn't want to share. So a neutral body came into place, and so this is where UNEP came in and said, okay, we're going to start and give A, capacity building. We're going to train you to collect data. B, if you don't have the equipment, we will give you the equipment. C, you give us the data. We publish the data, and your name is going to be on it, so you own your data. That really gave people the incentive to start collecting data and contributing. And voila, next thing you know, there is a chapter with the Rope Sea area that shows you the status of coral reefs in our region we've never seen before. Okay. So another thing is, we're not the only area around the world with geopolitical issues and tensions and low trust environments. And we've got two examples here, like the ICEN and the Arctic Council. What I really wanted to stress about is that, these models also show that flexible governance and building human capacities sustain cooperation despite all the rivalries and all of the competition that is out there. So the strategic pathways that we really need to be looking at is we really need to, champion decentralization. It is okay to not centralize things because we need to be more adaptive to the environments we're in. Second thing is about building trust. When you build trust, then you have networks within your peers. And that way, data is constantly moving. It creates collaboration modes, aligns with global standards, because when you bring everybody together, gives them that incentive and decide, okay, how do we standardize things so we can compare things? Things work out, and this is what we're doing on coral reefs in the Gulf at the moment. And lastly, you leverage your scientific networks from the ROPME, and just so you know, ROPME stands for the Regional Organization for the Protection of Marine Environment. And lastly, this is the agenda that we're working on currently for the Gulf region, that we are hoping that will not only help our region, but help regions elsewhere that have the same geopolitical tensions. So we're looking at utilizing mycelium as the metaphor, the model for Gulf biodiversity diplomacy. Data is obviously the foundation for climate resilience, food security, cultural heritage, etc. Prioritize capacity building and education. Strengthen national capacities for data management, because guess what? I come from a country where 2 marine biologists. We have 1 entomologist. We have 0 data scientists. Okay, how do you manage all of that? People always say, you're the marine biologist. I say, no, I'm 1,000,001. I have to do everything. I have to do the science, I have to do the policy, I have to do data analysis, I have to keep up with the world, I have to keep up with the latest science. But yeah, where is me? I don't know, don't ask me that question. Okay? And then we establish a regional data sharing framework, which is also something we're working about. And then in the end, you shift from biodiversity data as a liability to a shared regional asset. And with that, I will conclude. No, the nice picture of everybody. Andrew's also in there. And so Andrew's actually been one of our champions in the data diplomacy group, and GBF have been a supporter in trying to help us facilitate how can we bring all of this data up to the international platforms. Thank you very much.
Thanks, Reem. So we have no time for questions, but what I think we'll do is we have a discussion time right now. So there were some of you might have had reflections to this presentation or some of the other presentations. So hopefully these can come out in the discussion that we want to have here. And we started the session yesterday very much with this idea of, it's all based around the Kunming-Montreal Global Biodiversity Frameworks, the data that's needed for countries to report to that. We've gone through these global initiatives that are providing data to countries. Today we really want to talk about some of these national initiatives, some tools that are in place. And I think what I want to sort of focus in on this discussion here is really this national. How do we get, it's sort of touching a little bit on the conversation that Reem had in her discussion. How do we build capacity in countries for them to be able to report against some of these targets? And actually, today's session was quite interesting. We had a real range of things, I feel, in this session. Everything from people developing indicators in universities right through to sort of the geopolitics of the Middle East, essentially. And I guess the question I want to put out to you as an audience is, how do we get countries around the world to a state where they're adopting these indicators, adopting some of these tools that we're developing for reporting, and how do we get them communicating with each other and having that infrastructure in place for them to be able to effectively report against these targets. So I'm going to throw that out to you. Some of you have had practice working with countries, may have that. Some of you are developing tools. What are your reflections on how these can be integrated nationally?
I can maybe just say that as we are one of the 3 national bonds officially so in France, and I'm leading this node, I see that it's really complicated to involve national countries. In Bonn, for example, there is only 3 official national bonds, and there is quite a lot of regionals and others. I think this translates an issue. I think a little big issue is related to the fact that we need to have, I really appreciate the mycelium things, because I think we need to have decentralization and we need to have bottom-up approach. And for now, we see that, in fact, in national countries, they are all developing things, and when they are in the way maybe to contribute to something bigger, they maybe don't want to be, to lose what they are developing, and they don't really want also to use existing things. And there is money on that. The fact that everybody wants to have money to their research project and or for monitoring. In France, what we want to do is to make something where we strongly collaborate between research and public policy. This is something for us really important. We are trying since at least 9 years. I am on the node, and it's really complicated. But we see that if we have the good guys and if we use data also for diplomacy, sometimes we can go forward. But it takes time, and we need also to understand each other. Once again, I think the decentralization idea is really something which is key for me. We are imposing things, standard platform tools and things like that. Maybe we can just produce things, and with the people who want to reuse it, but maybe without forcing, because there is a lot of branding and things around that. But at the end, the indicators are not really coming from these kind of things, and there is a lot of data, as said by colleagues from private company, and there is a lot of data who are there. We are not using it, and even if they want to share it directly, and I mean raw data, not
derived data like GBIF data. We are working with people in private sector who have tons of images, sounds, a lot of data we can reuse for a lot of things. Yeah, but we need to give the possibility to each people, each local things to produce and to share the things, the manner they want to do, and try to accompany this transferization of data, source code and things like that, but not to force using things. And I think this is maybe one part of the question. Maybe another thing I see in France, for example, is that there is also a lot of data who are coming from report, who are going to minister, and they are under a desk, and nothing is arriving with this data. We can't use it, even if it's normally something we need to share. So I think at the political level, there is a lot to do. That's why also I think we need to have local action, territorial action. Biodiversity is local. So if people are involved, if they see there is a reason to produce metrics locally, and then this metrics can join a national and international point of view of the state or evolution of biodiversity, I think we can win, yeah, by 2 sentences or maybe 3.
I just think we have a wide variety of pathways that we need to use, and we need to build the infrastructures that support these pathways that are flexible enough. That will be key.
This idea of there being flexibility depending on different environments.
Something I started thinking about a while back, and was a moment for me. I was like, at some point in my career, I became a middleman, and we are serving people who are collecting data, and we are serving people who are using data. And it's not about us as data nodes or data share, like repos. It's more about those data contributors and those data users. And paying more attention to what their needs are has been what has been successful for us in Canada. So that's that flexible data entry. That's that flexible data sharing permissions where we have structures to meet people with what their needs are. So we're not saying, no, you can't have that covariate because it doesn't fit. So it's like, okay, we'll make custom covariates that are easy to implement. We're not saying, no, you have to have CC BY license. We're saying, okay, you can maintain control of your data but still feed it into these processes. And then on the other side, we've worked directly with the Government of Canada to learn what they're interested in terms of data products and trying to provide what they need from the raw data. And so it's like centralization is a huge value, and what we're doing in a way is centralization, but it's centralization not for the sake of centralization itself, it's to meet the needs of those two communities, and those really need to be in the forefront.
I'll just add to that from the indicator side. So in the development of our index, one thing that was really critical to us is sort of having conversations with the folks that actually are using the information, right? So meeting with local governments, with NGOs, with the private sector to understand what those needs are, and then how we can use sort of the data and the tools that we have available to provide them with that information. And so all of the sort of work, the development of the Biodiversity Progress Index was really driven by those sort of local information needs, and sort of gives us flexibility then to sort of modify our approach to better meet those needs as well.
Yeah, I'm kind of interested in this idea of are there effective mechanisms for connecting the data science to the decision makers? That's
I can speak a little bit to our experience with national governments and kind of like heads of state. Some regions, the countries are very competitive. So in the Middle East in particular, we've been working with some countries there, and they have programs of like competition basically like within the government, and they are very motivated to get their indicators at first for them to be accurate, but then for them to be collecting other data to show their progress that they're making to then be at the top of the leaderboard regionally. And so we've had a lot of engagement kind of tapping into that competitive nature of these governments, and have been working with them to refine the data to represent the local reality more. And so we've been engaging with them, and it's because they're really motivated actually by the score. And so I think that's something interesting as well.
Somebody over here? Somebody here?
Hello, I would like to thank Reem for her really engaging presentation and for actually describing biodiversity data as an asset. I think data products often get sort of intermingled with data. I think they're very separate because data are timeless, whereas the data products are going to change. You're going to have a new model, a new metric. There's 2,000, in a recent paper, 2,000 metrics for terrestrial ecosystems. Which ones are people going to choose from? Which ones are businesses going to report on? Their impacts, dependencies, and opportunities. So I feel like we need to kind of separate the asset that is data from the metrics and the indicators and the reporting tools, and really focus on getting financing towards the data for then better models, metrics, and tools for decision making.
Any reflections on that? I mean, the sort of funding part is something that I was thinking about as well, particularly watching your presentation, Alex, where you kind of develop this sort of infrastructure for countries. But then what happens once the project moves on? How is that sustained longer term, and how do we maintain these things going forward? I don't know if you've had any reflections on that.
Yes, I think, and it goes a little bit back to this idea of centralization and decentralization. And so a lot of these large NGOs are already investing in their own program, or like their own infrastructures, and the government already has theirs as well. And so it's tapping into that budget line that's already there, basically, and making it more efficient, right? So like having that all be in one place, even though they still have ownership of those pieces, it's decentralized in a way, but because it's relying on one system, the data cloud, like all of those costs are like 1/10 of the price as if everybody was doing it together. So as long as that trust is there and the infrastructure fits, we've seen, yeah, it's feasible to sustain it in the long term, you know, by tapping into these different budgets. You know.
I am getting my exercise.
With regard to funding, I can invite you to our session this afternoon. We are going to talk about funding for long-term sustainability of data infrastructures. And one idea that I would like to bring through into the world is that we should collaborate with economists, what we normally don't do. And we should look kind of like at the intersection between data value chains, natural capital accounting, and biofin methodology to kind of open up the data in an amount that actually makes sense for us.
Someone's asking which session? Okay, yes. Okay, we'll have to wrap up the session now. I want to thank everyone for following the sessions, especially for those of you who've been through for both of them. Some of the themes that came out here were sort of the mechanisms of connecting with decision makers. We have decentralization is a big thing that's come out. And some of this longer term sustainability as well is some of the things that I've taken away from this session. I want to thank everyone for being here. I want to thank my co-moderator, Lena, as well. And yeah, it's great to have you here. Please stay in touch. It's been a really good session. Thank you.